All right, hello, welcome. I hope this video finds all of you doing well. Where we're going next for Algebra 2 is we are going to go back and finish Chapter 8. We had tested on 8.1 to 8.3, which was graphing these rational expressions, which is, just something like, say, x squared minus 5 over x plus 2. That's a rational expression. And we graphed them in the first part of Chapter 8. And we're going to go back and finish Chapter 8 now. But before we do that, we're going to do a couple lessons on factoring, because these sections really, if you can factor, the rest of it's usually not too bad. So we're going to review factoring today, factor expressions like these, and help to prepare for 8.4 to 8.6. All right, so my first question for you is kind of basic. Just what does that word factor mean? Right, and I put a picture of myself because usually when I ask this in class, nobody knows the answer. And then I start crying. Here's my tears of nobody knows what factoring means. So see if you can remember what it means, right? Oftentimes I'll ask you to pause the video, think before you just hear the answer. So any thoughts what factoring means? Okay, so if you can't remember factoring, I always say just think back to a number. Like if you factored 42, all that means is to split it apart. So you can like split it into 21 times 2, and then you can factor it further because 21 splits again to 3 times 7. So basically factoring is the opposite of multiplying, and it says that like 42 is equal to 2 times 3 times 7. All right, so factoring, that's all it means. It's split it apart. All right, and so we're just going to factor these expressions. All right, some of which don't factor. These two are actually two expressions that don't factor, but that's what we're going to try and do is factor expressions. Okay, so just to review again, factor is the opposite of multiply. So you're used to this distributive property. Gives us 5x plus 15. Sorry for the poor handwriting. I'm writing on this little board, which makes it hard for me to write sometimes. But when you factor, it's just a reverse of that. So we are going to pull a number to the front. We're going to say what number is common to these two terms, and then bring that out front. In this case, they're both divisible by 6, so we put the 6 out front. And what we're left with is x plus 2. And please note that this thing is equal, right? This thing is equal to what we started with. We just broke it apart, right? Much like when we factor 42, this is still really 42 just broken apart. All right, so we just broke it apart, and then what we're left with is equal to what we started with. So factor, another way to think of it is the opposite of multiplying. Okay, so there is a whole bunch of different types of factoring. We learned about this previous in the year. There's all these different cases. I'm not going to go through all of them, but just know that not all of them are on this next test. All right, in fact, the ones you really got to know are this case. We're going to cover number 1 today in this lesson. And then also we got to remember that you always look for a GCF first, no matter what situation is in factor, always do that first. So in class, I used to write GCF on my arm just as a reminder that, that's what you got to start with. I recommend getting a GCF tattoo just in case you forget. And GCF stands for greatest common factor, like what is common to all the terms, right? So that's where we're going to start our factoring lesson is on GCF. So here's a few questions. Again, I'd pause the video, do all the ones that you can, and then unpause and see the answer. All right, so hopefully you've had a chance to try it, and you can see that what is common to these two terms here is they both have 2. I think 4 won't work, but 2 divides both of them. So we can bring a 2 to the front, and we're left with 4x plus 15. All right, next one, there's no number that evenly divides all of them, but they do have an x in common. So we can pull an x to the front. So we have x times x minus 6. Getting a little more complex here. These things are both divisible by 2, so we can bring that to the front. But they also both have x squared. So I'm going to pull out a 2 and an x squared from both of these. All right, so that'll be in the front. And then if you divide out 2x squared, you have a 2 and an x left up here. And back there, everything's been pulled out, so you just write a 1. If you're not sure, you can always like do the distributive property here and see if it equals what you started with, but that should be right. And then the last one is kind of a trick one. They don't both have x, and there's no number that evenly divides 17 and 6. So I put this one here just to be mean. That one does not factor, will happen sometimes in these questions. So that one does not factor. All right, 3 more for you to try like this. Go ahead, pause the video and give them a shot. All right, letter A, hopefully you know that there's an X in there, but this is going to come up in some of these questions too, where if there's a negative in front, you want to bring out like a -1. So on this question, our GCF is both -1 and X. So we're going to bring that to the front. So I'm going to take out a -1 and an X. And so what will happen in the front, all you have left is X. And in the back, the X will be gone, and then you switch the sign because you're dividing by -1, pulling it out. So this is no longer +5, but -5. Okay, another trick that'll come up in this chapter is if it's not in standard form. So basically, normally you want like the highest exponent first. So on questions like this, you're going to want to rewrite it so that the x part comes first and then the constant is second. And now pull out, I think they're both divisible by 2. So we'll pull to the front 2, leaving us with 5x plus 11. Okay, so that's a little trick, and that's going to be the same thing on C, where you want to rewrite it first with the x part first and the constant last. And then again, this one has a negative out front, so I want to pull out not regular 2, but -2. If we divide that out here, we'll have x and then -5. All right, one more kind of challenge question for you. This one's a little different. It's got 3 terms. Normally on a tough question, I would recommend just copying off your neighbor. That's generally like a good strategy, especially if you have a smart neighbor. But seeing as it's distance learning, you don't have a neighbor anymore, so you have to try it on your own. Okay, so hopefully you had a chance to try it first. So rewrite it in standard form where the highest exponent comes first. Okay, and then what is common? We have 3 parts now, but all of them are divisible by 9. I did this right. So I'm going to pull out a GCF of 9 and then just divide all the parts by 9. Right, and then later we'll learn this might factor further, this trinomial there. But for now, we'll just leave it like that and say that's good. And in fact, I don't think it does factor, so we would technically be done on this one. All right, part 2 for today is another type of factoring is called a square minus square. And so this happens when both parts are perfect squares and there's a subtract between them. Okay, so here's a list of a bunch of square numbers, right, which are kind of useful on these questions. Like the reason why I know it's square minus square is 16, 81, and 196 are on this list. Okay, so I'm going to do the first one, or if you know how to do it, pause the video and try all of them. Otherwise, you can watch the first and then pause the video and try the second too. So this first one, this thing actually factors into, to make the x squared, we need an x and an x. And then to make -16, we need +4 and -4. Okay, and you can get those numbers by looking at this little chart here. All right, sort of do the square root of 16 and that gets you those. And just if you want to verify that these two things are indeed equal, certainly you have x squared from here and you have -16 from there. But you also have 2 middle terms that cancel out here. You have a -4x and a +4x. Right, if we were foiling all this out, and those would cancel out and give us 0x in the middle. Right, so that's sort of the reason why this is equal to what we started with, x squared minus 16. All right, last two again. Hopefully you've already tried these. This one's going to be n and n for the n squared, and then the square root of 81, we use positive and -9. Last one's no different. it's just a little bit bigger number, but if I use my chart here, 196, the square root of that is 14. So I'd have minus 14 and plus 14. Okay, and if you had them in the reverse order, the plus 14 minus 14 here, that's the same thing. 2 times 5 is the same thing as 5 times 2. So it really doesn't matter the order that you write the multiplication in. All right, so here's some more kind of challenging questions for you to try. Again, pause the video and then unpause when you're done. Okay, first one, rewrite it in standard form first. So the positive x squared comes first, then the minus 25. Now it looks like our square minus square case. So we just factor x plus 5 and x minus 5, just like we did in the previous slide. B, this one's getting kind of tricky because 72 is not a perfect square number, and we don't have x squared here. But hopefully you realized, because you tattooed it on your arm, to take out the GCF first. So pull out a 2 first to get this. All right, and then from there, this is the square minus square case. So this remaining part factors to x plus 6, x minus 6. Okay, so that one factored twice, and you get that as your full answer. C was a trick question. That one actually does not factor. And it looks like the square minus square case, but because there's a plus in between, it doesn't work, right? It has to be a minus in between them. So even if you thought this was maybe y plus 10 times y plus 10, that's not going to work. These are not equal, because if you try to FOIL this out, you would get like a 20y in the middle and not a 0y, so that doesn't work. And then the last one is just a case students often forget. 1 is a perfect square, so this actually factors to m plus 1 and m minus 1. And again, if you doubt that, FOIL it out and you'll see that you actually get that as your answer. Okay, so why this matters, all right, is in 8.4, 8.6, we're going to start to simplify these rational expressions. And all you really have to do for this is to factor. So like this particular example, to simplify it, we just factor by pulling out an x from the top. And then just like we did in today's lesson. And then the bottom has a GCF of 4, so we can bring that to the front. Okay, and so once we factor it apart, we can say, oh, we got some common terms. So zoop, zoop, cancel them out. All right, and then we're just left with x over 4. Okay, so why this matters is when we simplify, it's really going to be about factoring. If you can do this factor step, then I think the simplify step will go okay. It's just, can you be able to factor? As long as you can do that, and the rest of the question's not too bad. All right, so that's where we're going. I think that's 8.4. So we're reviewing factoring to make sure we know how to do that. All right, that's it. We do have an assignment today. I know most days we alternate between assignment and lesson, but this is a pretty short lesson and a pretty short assignment. So hopefully you can blast through this quick. And as always, reach out to your teacher if you have questions. All right, hope you're doing well.